financially. So, and then the economic threshold, that's like the population size. The injury level is like the lowest density that you can cause damage, but the threshold is the action point. You guys get that? And so the equilibrium, what do you guys think that is? Like if there's a equilibrium position, what do you guys think that is?
The point where it's neither, like you're at like a crossroads where there's no definite, if I spray, it will help me, but if I let go, I don't have to spend money to spray, so it'll help me too.
Exactly, that's exactly correct. It's kind of it's the average density, so it's like it's like the point that's kind of normal, like the natural kind of population kind of. So, and so some examples of pest control, there's cultural methods, which is like how you grow your crops. And so that's like if you have like a greenhouse and you have like all these plants in your greenhouse and you just like let all the branches be on the floor, that's a place where the bugs can be, and so that can be very damaging for your business. And so it's a cultural practice to clean up after all the messes that you have. That can be a very good way to kind of manage the pests. There's also physical methods, so actually going into the greenhouse and like picking out the bugs compared to just like spraying or like releasing other predators or chemicals. So, and then genetic methods. What do you guys think that is? Yes.
GMO seeds.
GMO seeds?
Where you have a plant that is resistant to attacks from maybe a specific type of pest or a variety of pests.
Okay.
It depends on the strain of the plant.
Okay. All right. Over here, what do you guys think? Vicente? What do you think?
Could it be GMO bugs?
GMO bugs too, that's definitely right too. So the plants themselves and then maybe other insects. So, yeah. Then there's biological methods, so it's like predators, parasites, diseases, and so the pests that manage those pests. So then there's chemical methods, which is like the last case scenario. That would be like the spraying the pesticides. And then the regulatory, that's like preventing the situation get there to begin with. So you guys know like citrus greening, a strong way to try to prevent that part of the IPM is to make sure that it's not there in the first place, and so regulating what actually goes in to affect those crops. So avoiding this situation altogether. So next we're going to have a case study that I'm going to have you guys look at. So guys form into groups of two. Groups of two. Or since you guys are groups of three, I guess then. Alright. Okay. Okay. Maybe has about 4 minutes to read that. Or less, eyes on me when you guys are done so I know when we can move on to the next thing.
I made him, I just didn't say what for
Alright, you guys done over here? Alright, cool. So next, as a group, you guys are gonna talk about these next questions. So how might a cockroach be a pest? What elements of IPM do you see in this that could be addressed? What type of methods might you use? And when might there be a threshold for action? And then also, how might you rate the success of like the management? So,
Used control.
You don't, right?
Yeah, that'd be, I mean, I don't know.
I don't know, because it just said how the bait.
I don't know what a predator to cockroach would be.
we don't have to be very specific, like you said, you wanna use a predator, that's a
Well, my
method.
dog.
You could use a predator,
Don't just
something
know.
like that.
No one loses.
For chemical bombing.
But I mean, like, you.
So that's also, remember, that's like last case scenario, so what methods,
Because
yeah, that's true,
Yeah.
then you might have to resort to that, but if at all possible.
you can still use chemical too. Chemicals are proven that it wears off. They adapt.
That's what you thought.
Professor, what's up?
For a cockroach, maybe like different insects, or rat, bird, lizard.
How's a bird gonna work that? They get in your house.
Well, I meant not like a pigeon or anything like that, maybe. But I mean, I want my parrot.
Or like a little like crow, like a sparrow.
Yeah, right. Wouldn't that fly around my house?
I want something that can get in the walls just like a cockroach can.
It's gonna be so weird, you're gonna like fight them in the woods at night.
Exactly, that's why bird bolt.
Why not?
Oh, what? Oh, yeah, he's crazy.
It's my luck.
When might there be a threshold for action? I mean, it depends on your preference, your situation. If you got somebody who's asthma prone, then as soon as you see signs, that should be a threshold.
Yeah.
If somebody really, really hates it, and starts to see it,
Physical
I
reaction.
feel like it's all
that's the
described to me
threshold.
like, I got asthma, I have a whole ear infection.
Makes sense, we hate roaches.
Alright, yes, so, let's hear from this group over here, so, why might a cockroach be a pest?
They get in your house and multiply, so there'd be a lot of them, and they're germs and they can spread germs, and apparently they can cause asthma.
Okay, so disease and asthma and stuff like that too, yeah, that's definitely one thing, okay, so I saw a hand over here.
I was gonna say the same thing about the asthma.
Okay, asthma, okay, so anything else from you guys?
They're just like a nuisance.
A nuisance, they just be like around you, you'd be annoying, like fucking around, yeah.
And people just straight up don't like cockroaches.
Yeah, that too, maybe just like a preference, maybe a phobia.
Yeah.
Yeah. Okay, and so what elements of IPM do you guys see here? That could be, that you could use,
Well, we read an article about the bait.
so baiting, so like a trap,
The
okay,
jail bait.
what chemicals? Predator, you'd do that,
We
okay.
don't know how we'd actually apply what predator we could actually get, but that's an option. If there's one out there that would be a pest as well.
Yeah, cause like balance.
It's like, I don't know what else you'd use besides chemicals.
Yeah. So what are you guys over here, what are you guys thinking?
Same thing.
Same?
Yeah.
Okay. Alright, so what type of method might be effective in this situation?
Maybe, I feel like the only thing you can probably use is more chemicals, cause like, with the pests, like, probably like, I mean, it's not really something else you can add to that situation, like, you're gonna put a pest on top of another pest,
Yeah.
it's like, it's not good.
Yeah. Or like rotation of chemicals maybe, or something
Right,
like
yes.
that? Yeah. Okay.
Prevention.
What?
Prevention.
Prevention, so like regulation, so you make sure that there's not opportunity for those bugs to get there in the first place. Make sure there's like a boundary for them, yes.
Alright, so what we're gonna do, because it is 1:25, we only have 15 minutes in the class. We're going to kind of stop where you're at, because I think you were starting to, in this case study, and then probably a review.
Yeah.
So maybe just kind of tell us real quick what you would do with your review, and then we'll call that good, and then you can kind of go ahead and start setting up as well. Just because I don't want, we have to get at least one more person
Yeah, sure.
in, and I don't want to hold the next class off too much.
Okay.
So we'll give you a round of applause. So I think you're doing a great job. Sorry that I interrupted you. But how about just tell us how you would do your review, and then something that went well, and where you can improve.
Okay, so after that, I would do a reflection. It's like, so what do you guys learn today? What do you think, do you think you'd be less likely to spray if you had the chance? And then kind of like go around, ask, like, see if there's any questions, and then after that, I would have like an exit ticket, have them go home and find one type of like specific control that they like maybe, oh, like they really like predators. So maybe they come back to the next class before, and they tell you like what type of predators they thought was really cool, or maybe it's like the prevention or something they thought that was very interesting. I thought that'd be a good way to kind of get them into IPM, to get them reading more of it on themselves. So I think I was I think I might have been a little slow and maybe a little dry in kind of the lecture. So I think I should probably have gone through it a little bit more, maybe practiced a little bit more. And then maybe kind of like maybe spice up the slides a little bit. Make it more interesting. It's usually kind of boring. Make it a little more clear.
Okay. Comments?
I agree with you on the visuals, but a little more. I think, but probably it is pest management, so not everyone's gonna be comfortable with it, pictures of bugs.
Pictures of bugs would be like interesting to the past, so getting attention. But I think you did a good job of like introducing different techniques, because like when you asked us how we kill bugs, I was like, just bomb them, you know, just kill them. So other ways, like less drastic ways to control this.
I really liked your little bugs you brought in.
Yeah.
The pains of writing here.
What?
Yeah, how that sound works?
No, that's my computer, bro.
That just did that?
Yeah, I have my computer too now.
Okay, Bo, a couple quick comments that I have. So overall, I thought you did a great job. We've seen a lot of really good interest approaches in here so far, but I think that may have been definitely one of the better ones with the different bugs. I think that was really cool. I got everyone excited. One thing I would suggest though would be to put your objectives after the interest approach. The students are excited, and then this is what we're gonna learn today, this is why we're gonna learn it. So it really kind of ties the two together a bit more, instead of here's what we're gonna do today, and then let's start it, then with, so interest approach, then objectives.
Okay.
Okay. I really like the case study. I thought your PowerPoint and your lecture, excuse me, your lecturing wasn't bad. Maybe just a few more times where you ask students questions to get them more engaged throughout the lecture. But I thought you seemed really knowledgeable. I thought the PowerPoint slides were pretty good. So don't criticize yourself too much in the lecture. I thought it was good.
I don't think I was extremely accurate with the information as I could have been.
Okay.
So
Can I do what?
Thumb drive in the air.
Why?
Okay, Andrew.
Alright, so do you want me to hurry up and run through it briefly, or?
No, I want you
I
to do it like how you normally present.
Okay.
And keep in mind, I may stop you at some point, just
That's
like what I
fine.
do with Bo, and say, okay, how would you continue this?
Well, I mean, I've got some videos and stuff, so I may pick and choose.
You do that, or you can just do it as you normally would.
Okay. Alright, hey guys. Today we're going to be going over a little bit about secondary processing. Alright, to recap, can anyone tell me what we did in our last class session? Anyone? Yes, Austin?
We pasteurized milk.
You're right, we did pasteurize milk. We learned how to pasteurize milk, why we pasteurize milk, and the process behind it. Now, how do you think what we covered in the last session will relate to what we're covering today? Just a broad spectrum about secondary processing, taking pasteurization, and then putting it one step forward. How do you think that we would make? Awesome.
Making chocolate milk.
Making chocolate milk. That's actually pretty cool. And I've actually got a video. Starts off with a little bit of chocolate milk. So what are some products that you think are that you think can be processed further beyond, say, pasteurization, besides chocolate milk? Kelsey?
Is it like cheese stuff?
Cheese, yeah. Anything else? Bo?
Pasteurized,
After pasteurization. So if we take the pasteurized milk, what do you think we can do with that pasteurized milk then to make a new product?
cheese.
Cheese?
Yeah.
Vicente?
Ice cream.
Ice cream, yeah.
Yeah.
Kelsey?
Yogurt?
Yogurt? Yes. Anyone else? Okay, awesome.
Creamer.
Creamer? Yeah. We actually, yeah, we'll just leave the cream on top. Alright, so we're gonna go and watch this quick video here. Hopefully it'll work. Don't mind all my tabs, guys.
You might have to exit out of the PowerPoint
I
view.
think it's frozen.
Do I?
Yeah.
Ah,
Just hit maybe escape.
no, it doesn't. It's weird. Huh. Yeah, cause now this isn't even working. Hold on, guys. No, you're fine. Well, and then I put my own thing.
Can you try to go back to the PowerPoint?
Yeah,
And bring it up?
cause this is here, so,
And then press escape?
escape. In focus? No, cause that went back to that. No, there we go.
And now I can minimize that. And that doesn't think it might have to look anywhere. You're live now.
Yeah. It's still not gonna play sound.
I heard something.
Alright. Well, this is fun. Yeah, that's gonna yellow.
Facility here and tell us how everything comes in and then how it gets out to the bottles. Sure.
Alright.
The Cultured Farmer is brought to you by Oregon Dairy. Hi, welcome to another episode of The Cultured Farmer. I'm John Gaiman. We're here with George Hurst. We're going to take a look at the milk processing facility here at Oregon Dairy. This is the second part to the other series we did with the milking over on the farm. So George, thanks for showing us around today. Sure. And if you could just walk us through the milking facility here and tell us how everything comes in and then how it gets out to the bottles.
Sure, be glad to. This is the milk truck, the tanker that we use to bring the milk from, up from the farm. Every couple hours before we're ready to start processing, we bring the pulled milk up. We process directly from this truck right into the processing plant. The milk is pumped from the truck into the clarifier, the milk or the milk separator. This separates the cream from the milk. We put it in these tanks and then we sell the cream.
To make
Take
sure.
it to a local ice cream plant. They actually make our ice cream with this. After it's through this machine, it goes through the homogenizer. The homogenizer is what breaks the cream into molecules. That way, when you have the milk in a container, jug, splash, or whatever you put it in, we use plastic, the cream won't separate to the top. If you just don't break that up, you'll have a layer of cream on top. After it's through the homogenizer, it goes through what we call a high temperature pasteurizer. This has plates in it where the milk is pumped in there, and with hot water on one side, and the milk is pasteurized at roughly 170 degrees just for a couple seconds, and immediately goes down to another set of plates where there's ice water running down in between, and immediately cools the milk down to 36 degrees again. That all happens within a couple seconds time. That's why it's called a high temperature, short time pasteurized. This particular panel is really important. This actually records our milk temperature. It records all the milk as it's being processed, how high the temperature goes up, how quick the temperature drops again. And that's recorded on the graph. After through the short time of the pasteurization process, we put it in one of these two holding pans and keep it there until we're ready to bottle it. This is also a mixing tank. That's where we mix our chocolate milk and our drinks and so on are also mixed in that particular tank. And it's an holding tank. We're ready to start processing or packaging it. This is where the milk is pumped into, actually in this
That's
here. The bottle's on here. This is where the
Alright, now I wanted to go ahead and show you all that video today because a lot of you were asking questions about further than just home pasteurization last class. You wanted to know more about industrial pasteurization, so that's what I wanted to show you all that for. And let me get back to the PowerPoint. No. Maybe. There we go. It's gonna be good. Maybe I can do this one. Alright. Alright, so again, I just wanted to show you all that. A lot of you were wondering about industrial pasteurization last class and we ran out of time, so figured I'd just show you all that. Alright, now today we will be covering basic secondary processing products to further go into detail about those products in future weeks. Okay. Alright, now, can anyone tell me right now what are some basic secondary products that we use in everyday lives besides your cheese and besides those dairy products? Anyone know? Toothpaste, yes.
Soap.
Yep. Shampoo, yeah. Clothes, yep. Pretty much every single agricultural product or commodity can be processed one more time, so that way we can get other products out of them. Now today you will be able to successfully identify those products in our everyday lives that have been processed to a secondary level, and you will understand the process behind secondary processing of popular dairy products. Alright, so the three secondary processing products that we're going to focus on today is going to be cheese, soap, and ice cream, all of which we've already hit on earlier in this lecture. Alright, so now we're going to go into how to process dairy products. Processing cheese. Does anyone know the main component of cheese? I guess you could. No problem. Milk. Alright, correct. Does anyone know how cheese is made? Rebecca, do you know how cheese is made? No? What about you, Kelsey? Trade it somebody.
I know it's like this store for a while, isn't it?
Mm-hmm. Yep. Austin? No, that's one. What do you have? Bob? Same? Alright. Yeah.
There's some sort of storage and then there's something called curd, I think.
Mm-hmm. Yeah, there's a few different.
Yeah, but
Yeah. Any other questions about how cheese is made? Well, actually, go to this another video. This thing doesn't like me, so. Sorry, guys. Technical difficulties.
Like all cheeses, mozzarella starts from milk. To assure good milk quality, the interior and exterior of tank trucks transporting milk must be washed after being emptied. A tank such as this one can carry an average of 30,000 liters of raw milk at a temperature of 3 or 4 degrees centigrade.
Raw milk destined for cheese making contains 3.8% fats and 3.3% proteins. They store the milk and whey, a milk byproduct, in these immense silos, each with a capacity of 225,000 liters. This milk separator extracts surplus cream to adjust the percentage of fat according to the type of cheese to be made. Fabrication begins with this tank, which feeds the pasteurizer. Pasteurization sterilizes beverages which can easily ferment. Milk samples are drawn off to precisely determine their milk fat and protein content. Tests are carried out in this laboratory where they impose controls. These test tubes contain milk samples which will undergo microbiological analysis. Milk quality must be impeccable. This is a curdler with a 25,000 liter capacity into which milk and other essential ingredients for making mozzarella are introduced, such as the enzyme rennet that curdles the milk. This mix must be well stirred and cooked. The agitators are used to cut the whey into little lumps. This step takes about 30 minutes. The temperature of the tanks depends on the type of cheese they're making. Agitators continue stirring the milk. Once cooking is done, the whey is pumped onto tables to be drained. It stays there for about 25 minutes. The solid and the liquid are now well separated. The liquid we see draining is called lactoserum. The lactoserum will be concentrated and transformed into milk byproducts. The water has been almost entirely extracted and the cheese particles are now sufficiently dry. This large automated blade then moves cheese particles towards the next step. That is toward the molder.
Okay, so what we're gonna do, since we're already 2 minutes past our time to leave, I don't wanna keep you all here either, and then the class waits. So maybe Andrew, just tell us how
Yeah.
you would wrap up this activity.
Alright, so
for
we
this
go
lesson.
through this cheese making component, and then we would continue to ask questions about how cheese is made. And then we'd run through soap doing the same thing, but I have an actual at-home soap little presentation, because you can make soap at home using milk. It doesn't take long at all. Same thing with ice cream, but a lot of us have made ice cream in agriculture classes before in bags, and I found a way to make it in a bowl, a little bit more time consuming, or less time consuming than sitting there shaking it in a bag.
Okay.
So I was gonna do that, and then bag or no bag type little thing, like what do you think we should do?
Like with a video or
Yeah.
with an actual?
Well, there's a video and then questions about either what we do bag or no bag. And then I have a Think, Pair, Share,
Okay.
where we would partner up, discuss in partner groups what your favorite secondary process product is, whether it be one of the ones that I explained or one that you want. It be anything that you feel is processed to a second level. We think about that by ourselves, pair up, and then share it as a class discussion to get more broader views on topics. And then, again, class discussion. And then, exit ticket, sheet of paper, just so I know that everyone's paying attention, your favorite secondary process behind the process that the product undergoes and why it is your favorite type.
Okay, cool.
So, yeah.
That works. Any quick comments or questions or?
concerns?
Yeah, Sensei?
Yeah,
I wish you would have explained material before trying the video.
yeah,
Really
I-
important.
yeah.
This is really good though.
Okay.
And, I don't know, looking at the content of the video now, it's kind of be hard to explain if you were to have that
Yeah.
issue.
I feel you.
Um,
Well, I mean, in 20 minutes,
We-
trying to
yeah, no.
explain,
I
it's a
know,
broader topic, and I ran into some difficulties trying to.
yeah, I get that. But
Yeah.
I'm also saying that, you could explain a video if possible instead of going through all that to show it.
Gotcha.
All right, good stuff. And one thing I'd add onto that as well, I think it was a great idea to having like different videos for each piece, and that's a great tool to foster discussion and things like that, showing those videos. I was just kind of add on maybe just to say like what the purpose or what do you want the students like to
To take away from the
take
video.
away from or like look for when the video's going.
Yes, sir.
Overall, I think you did a great job for the resources that we kind of had and the tech difficulties
Jumping
and
back and
time frames,
forth,
stuff
yeah.
like that. So, all right, that is all I have. So if you presented today, I